Hello, I'm John Fitch. Man, since the beginning of time, has wondered about the stars and the planets. Our neighbor planet Mars has intrigued the imagination of artists and writers. Some people think there is life on Mars. Some people think there are strange creatures on Mars. We've been looking at Mars the way artists and writers imagine it, a planet of jungles and deserts, inhabited by monsters and, of course, beautiful women. Well, I'm happy to say that they are wrong. Mars is far more mysterious than that, and far more surprising. This is an example. It's a bit of the Martian weather that we've reproduced for you. No. It isn't snow, it's a different kind of weather that scientists have predicted that we may find on Mars. This is the theory. If the Martian atmosphere contains carbon dioxide and methane, and they are exposed to the ultraviolet radiation of the sun, they may produce sugar. In other words, there may be a constant sugar fall on Mars. This is not the only reason why the United States has sent a probe called Mariner 4 more than 325 million miles through space for the first close inspection of our mysterious neighbor. Scientists in the U.S. are launching many types of spacecraft to collect important information as their contribution to world knowledge. Among them are scientific satellites which orbit the Earth, and deep space probes, which the United States has already launched to photograph the moon, examine the planet Venus, and now to investigate Mars. Scientists at the National Aeronautics and Space Administration, who direct these operations, have been seeking answers to many questions. Are these really canals on Mars? Are the polar caps frozen water? Are these dark areas vast plains of vegetation? How thick is the atmosphere, and how hard do the winds blow? Does the planet have a magnetic field so that future explorers' compasses will always point north? You notice I said future. The Mars Mariner probe is only the first step in a series of scientific explorations which have been planned to answer the most important question of all: is there life on Mars? The first step is always the hardest, and it was an incredibly complex job sending the Mariner probe to Mars. It was a miracle of engineering skill which is difficult to understand. I think I can describe it if you'll think of the Mars probe in terms of something most of us have done: taking an automobile trip. The first thing you do when you plan your trip is look at a road map. Say you want to drive from Columbus to Indianapolis. You have a choice of many routes, some good, some bad. American scientists did the same thing when they planned the trip of the Mariner probe to Mars. This is a space map of many routes from Earth to Mars, some good, some bad. Now, this one is bad because it would take too long. A spacecraft is like a car. It can't go on forever without repairs, and a probe can't live forever in space. Mariner's maximum life is estimated at 6,000 hours, or 250 days in space. This route is the shortest and the quickest. It's a direct shot at Mars, but it can't be used because it demands too much power. Anyone who's ever tried to ride a bicycle up a steep hill knows what that means. When the hill gets too steep, you just run out of power. And this trajectory is too steep. So we pick a compromise route, one that is not too long and doesn't require more power than is available. The next problem is, what do we take the trip in? This is a model of the spacecraft designed and built by the Jet Propulsion Laboratory in California. The Mariner 4, which has just made its historic encounter with Mars. Or, translating it into automobile language, it's the equivalent of the latest sports touring car. Light, compact, and powerful. And it has parallel equipment. For instance, the radio on the Mariner Mars probe. Gas jets for controlling the probe in space. That is, steering it, so to speak. An optical system to see where it is. Solar panels, which collect energy from the sun and store it as electric power in batteries, much like the generator and battery in a car. Storage space to carry the scientific experiments which are the luggage of a space probe. In other words, Mariner isn't just going to be first to Mars. It wants to do useful work on the way and when it gets there. And everything, spacecraft and experiments, controlled by a central electronic system like the dashboard of this car. This gear for maintaining the probe in space is nicknamed the housekeeping equipment. This gear for maintaining the probe in space is nicknamed the housekeeping equipment. It must operate automatically because we can't get an immediate response when we send it orders from Earth. The Mariner is so far away that when it reaches Mars, it will take a radio command 12 minutes to reach it. And then we must wait another 12 minutes for its acknowledgement of that command to reach us. That's like a traffic policeman being forced to wait a half hour for his signals to be obeyed. In the space left over from the housekeeping equipment, the scientists packed many experiments. Thank you. One is the equivalent of a net to catch and count cosmic dust. This will be important information for engineers around the world who are planning on sending men to Mars. They must know if the craft will run the risk of being punctured in space. This is what the device on Mariner actually looks like. What's this, lunch? Oh. Now, magnetic fields are of vital importance to everyday life. Can you imagine a ship or airplane trying to operate with a compass that doesn't work? Well, there's a magnetometer on the Mariner probe to check Mars for magnetic fields. This magnetometer is an electronic compass and is even smaller and lighter than this ship's compass. Now, space is not empty. It's filled with burning particles traveling almost at the speed of light. On the Mariner, this is an ionization chamber to measure high-energy particles in space. Now, let me demonstrate with this child's toy. When a particle passes through the ionization chamber, it is multiplied, like this. And a Geiger counter also counts the particles. Now, this is extremely important because scientists must know how much deadly radiation men will be exposed to when they make their trip to Mars sometime in the future. One of the most interesting experiments is the plasma probe, which is the electronic version of this radiometer. Did you know that there's such a thing as a solar wind? Well, when your radio, television, and telephone communications break down, it's usually the result of solar wind activity. The sun boils off huge amounts of radiation that blow out through the solar system like a hurricane. I'll show you. David, do you think you could switch on those lights without turning on anything else this time? Well, now, the radiometer on Mariner responds to the light pressure which presses against the vanes and makes them spin. Now, watch what happens when I expose them to strong light. Now, this is a miniature version of the solar wind. Multiply it by the size and energy of the sun, and you have a hurricane of light and high-energy particles blowing out into space. All right, you can switch off the lights. Now, you may not think that radiation is important to space travel, but if the experts at the Jet Propulsion Laboratory hadn't allowed for light pressure, the Mariner 4 would have been pushed off its course by 10,000 miles. This is a very difficult concept to realize that light pressure will be as important a factor in the space travel of the future as ocean currents are in navigation today. And the most dramatic experiment of all, television. Now, this is a studio TV camera. I don't think that will fit into the car, but this TV camera on board the Mariner is much smaller. It will take about 21 pictures. We'll show you the kind of job it was capable of performing as soon as we launch our space probe. Oh, no, I'm sorry. No passengers on this trip. You'll have to wait your turn until about 1980. This time, we're just going to launch the probe. This is the actual launch of the Mariner Mars probe from Cape Kennedy in November 1964. The craft was boosted up into a parking orbit by the Atlas Agena rocket. At precisely the right moment, the probe was inserted into trajectory and its 8-month voyage began. It was tracked by an international network with stations in South Africa, Australia, and California. Launching a spacecraft is a lot more complicated than starting a car. I'd better tell you something about the ballistic skill required of engineers to send a probe to Mars. Most people think it's like shooting a gun. You take aim and fire. It's not as simple as that. Engineers had to do two things. First, they had to boost the craft into an orbit that circled the Earth. Spacemen call this the parking orbit. Then at precisely the right moment, the second stage rocket was ignited to insert the Mariner into its trajectory for Mars. It was very much like a tennis service. Watch. First, you loft the ball into the air. That's the boost. Then, oops, well, try it again. The boost with the Atlas rocket once more. Now, when the ball reaches the top of the toss, that's the parking orbit. Now, boost, and there. You see, the racket hit the ball and drove it into its course. That was the Agena second stage rocket inserting the craft into trajectory. But it isn't over yet. Now the tension and the suspense set in. We still don't know whether the probe is exactly on course. If it's off course by as little as 1 inch in a mile, it will miss its target by 6,000 miles. Engineers and scientists must wait while stations around the world track the probe. They wait at Cape Kennedy, at control centers in the Jet Propulsion Laboratory in California, and at the Goddard Space Flight Center in Maryland. They wait hour after hour, day after day, while the radar trackers and computers report on the course of the spacecraft and analyze it, until they know precisely how the course must be altered to put the probe squarely on target. And now the delicate mid-course maneuver must be performed. The gas jets and the rocket engine on board the Mariner must be activated by a radio command so that they may steer the probe. They may thrust at just the right angle for just so many split seconds, or the entire mission will fail. Engineers and scientists compute angles and thrust. the data is punched into a command. The command is sent 1,000,000 miles through space to the probe. And then they wait again, 5.5 seconds for the radio signal to reach the Mariner. And then another 5.5 seconds for the reply to return to Earth. This is the mid-course maneuver, one of the biggest challenges of space travel. Listen, did you hear that? Well, that's the voice of the Mariner speaking to us from deep space, telling us that the mid-course maneuver was successful. Engineers had prepared for a second maneuver if the first failed, but the first was so accurate that a second will never be needed. Meanwhile, the Mariner has been sending back vital data on cosmic rays, magnetic fields, solar plasma, that's the solar wind, radiation, and cosmic dust. The data goes into the computer and comes out on this printer. This information is made available to scientists all over the world, and they can read it, whether they're English, Spanish, French, or any other nationality, because the U.S. shares an international language with them, mathematics. Now, did you hear that short burst? Well, that was a command from Earth for the television camera on board the Mariner to prepare to take pictures. The probe is closing in on Mars for the encounter. It won't land on Mars. It will sweep around at a distance of about 6,000 miles while its camera takes 21 pictures. Now, this is the way the moon has looked to man since the beginning of time. It still looks the same to us today, but now we know what all those markings are which mystified our early ancestors. Because 350 years ago, Galileo looked at the moon with his primitive telescope and saw this. The markings were revealed as craters and mountains. It was one of the biggest breakthroughs in the history of science, and scientists are still benefiting from Galileo's great discoveries today. This is the way Earth-based telescopes see the planet Mars. Our best telescopes can't see Mars any better than the naked eye can see the moon. And we're as mystified about the markings on the planet as men were about the moon 4 centuries ago. But we're about to come as close to Mars with a television camera as Galileo came to the moon with his telescope 3.5 centuries ago. The technical skill required to transmit these pictures back to Earth was truly impressive. Each picture consisted of 200 rows, each made up of 200 dots, much like the half-tone photographs that are transmitted by wire photo and published in newspapers. Each dot is radioed back as a number. Each number runs from 0 to 63, designating varying shades of blackness, transmitted as bits of information, 6 to a dot. The numbers look like this when they come in, and it takes 8.5 hours per picture. At the Jet Propulsion Laboratory, a computer takes this information and, working with sheets such as this, reconstructs the picture dot by dot. This is man's first close-up photograph of another planet. Scientists who have examined Mars through telescopes are praising them for their clarity. These are 30 times better than any photograph yet taken. Looking north from the Martian equator, it shows a bright 200 by 600 mile area on the rounded edge of the planet. The lofty clouds at the upper right are believed to be dust, whipped up to extraordinary heights by the violent Martian winds. This picture on the western edge of the Amazonas desert is still clearer and shows physical features down to 2 miles in length. The crater-like object at the center is about 12 miles wide. When picture number 7 came in, it was a dramatic moment for the Mariner scientist. For the first time, craters, as well as other variations on the surface, were legible on Mars. The discovery of craters on Mars was the big surprise of the picture. The scientist confessed to being shocked beyond belief. Picture number 11 has been called one of the most remarkable scientific photographs of this age and was the pinnacle of the picture experiment. It resembles the moon's surface so much that the scientists now believe Mars, in its evolution, is more like the moon than the Earth. The largest crater you see is 75 miles across, and like other Martian surface features, is now estimated to be very ancient, up to 5 billion years old. All the evidence indicates that the craters were created by impact rather than by volcanic action, and there are an estimated 10,000 craters on Mars, compared to a handful on Earth. The long rim-like feature you see in picture number 13 could be the edge of the largest crater revealed by Mariner. It is thought to be 13,000 feet high, and its eroded, rounded shape is comparable to the moon craters. Because these features of the Martian surface are thought to be largely unchanged since Mars was formed, scientists have come to another conclusion. They believe there hasn't been enough free water on Mars since the planet was born to have rivers and oceans. For if there were that much water, Mars would be more heavily eroded, just as the Earth is. Note the white rings around the craters, probably frost. The surface of Mars is very cold. The same white rings which appear on picture 14 of the sequence may be more frost, and the white patches could be small peaks covered with frost. The frost, incidentally, would be of no help to plant life. For plants to grow need free water, and there seems to be none on Mars. The absence of mountains and continents on Mars, say the scientists, shows the interior of Mars has long been inactive. Earth, having a dynamic interior, produces the same features by stress and deformation from within. But Mariner 4 would have made history even had it sent no pictures. From its experiments, scientists are able to leave speculation behind and to construct on the basis of hard information what they know about Mars. They know now that the planet is even more inhospitable, more desolate compared to Earth than it was thought to be. As Mariner flew by, radio signals passing through the Martian atmosphere established that the air pressure on its surface is about 2% that of Earth. So thin is this atmosphere that braking rockets, very large parachutes, or both, will have to be used in a Mars landing. At the same time, this highly thin air must blow with terrifying force to cause the dust storms that periodically seem to cover much of Mars. And because of the thin atmosphere, astronauts on Mars will have to wear spacesuits just as they will on the moon. The scientists know now that Mars has no significant radiation band around it like the Earth's Van Allen belt, that it is ringed by no belt of cosmic dust, nor by a shock wave caused by solar wind. The upper layer of electrons that make possible shortwave radio communication on Earth is twice as low on Mars. Man on Mars will not be able to navigate with a magnetic compass. The lack of a magnetic field suggests that Mars, unlike Earth, does not contain a molten core. The thinness of the air and the absence of a magnetic umbrella above the planet means that Mars is bombarded with more radiation than Earth, about 50 times more, but not so much that an astronaut couldn't explore it for brief periods. The scientists who have examined Mariner's pictures are not yet willing to identify any of the controversial canals. These and other conclusions about the planet's surface will have to come later. Is there life on Mars? If there is, it will have to be the kind that could survive on a platform 20 miles up from Earth, where the atmosphere resembles that of Mars. A final answer will have to wait on instrumented landings by Voyager spacecraft in the 1970s. More information is still to come, but Mariner 4 is already the most successful and important feat of the space age, as well as one of the most brilliant engineering and scientific achievements of all time. This is not the end of Mariner. From Mars, it will head into permanent orbit around the Sun. 3 years from launch date, November 1964, Mariner will again come close to Earth. American scientists will then attempt to contact Mariner once more. As for Mars, one of the Mariner 4 scientists observed, Mars was so distant, but now that we have reached the planet, it seems to be part of us. This is only the first look at one of our sister planets.